Okay, I'll just remind you how to do normal number fractions. For example, 3/4 plus 2/5. If the denominators are the same, it's easy. You just add the numerators. Okay, numerators on the top, denominators on the bottom. So I have to, because the denominators are different, 4 and 5, I have to rewrite equivalent fractions with the same denominator. Now, I'm going to choose the 20 as my new denominator, and I got that by going 4 times 5. This fraction, I had to multiply the denominator by 5 to get 20. Therefore, to make an equivalent fraction, I have to do the same to the top one as I did to the bottom line. So 3 5s are 15. So 15/20 is the same thing as 3/4. With this fraction, I multiplied the denominator by 4. Therefore, I should have to do the same thing to the top line. And 2 4s are 8. And 8/20 is the same thing as 2/5. It's equivalent fraction. The good thing though is that the denominators are the same. I can just add 15 plus 8, which is 23, and the answer is 23 over 20. Now that was a flashback to year 9. Now we're going to do that using same principles, but using some algebra or some letters. So let's say I've got x over 2, and I want to add, say, 3x over 5. I can't go ahead and just add the numerators. I have to write two new fractions with the same denominator. What number shall we choose? 10, thank you. Why 10? Because it fits both 5 and 2, or because it's 2 times 5. That's where the 10 comes from. This fraction was multiplied by 5 on the bottom. I should therefore multiply it by 5 on the top, because I want it to be an equivalent fraction. 5 times x is 5x. This fraction was multiplied by 2 on the bottom. I therefore should multiply the numerator by 2 to make it an equivalent fraction. 2 times 3x is 6x. Now it's easy. All I have to do is add the numerators. 5x plus 6x, and if I do that, I get 11x over 10. Can I simplify this anymore? No, that's my answer, 11x over 10. Okay, where you have a fraction and a constant, you have to turn the constant into a fraction. To do that, what should I divide by? What should I divide by to make it still the same number? What goes down here? 1. I'm horrified whoever said 0. You can never divide by 0 in mathematics. Right, now I've got two fractions, so I solve it in the same way as I just showed you. I need to make the denominators the same. What number should I use? I think I heard someone say 5. Well done. And that number came from 1 times 5. Look, 1 times 5. 5 goes into 5 and 1 goes into 5. So use 5. This fraction was multiplied by 5 to give this 5. I therefore have to multiply the top line by 5 to write an equivalent fraction. 3 5s? 15. Notice, if I took 15 divided by 5, I end up with 3, which is what I started with. Right, this fraction was multiplied by 1, I therefore multiply the top line by 1, and it's just x. Now I can do the subtraction of the numerators, and because I've got equivalent denominators, I can just write it over 5. Can I simplify this anymore? No, you can't. You can't. You have to do the subtraction, then divide by 5. You can't divide by 5 and then subtract. Same idea. It looks complicated. It's not. You're looking for two equivalent fractions, and I'm going to choose 20. And I think you all know now why I'm choosing 20. This fraction was multiplied by 5 on the bottom to get 20. I therefore should multiply the numerator by 5 because we want an equivalent fraction. This fraction was multiplied by 4. Therefore, multiply the numerator by 4. Right? There's a plus in here. 4, 2x minus 1. Okay, therefore I can write the whole fraction over 20. And on this top line I can actually do the addition, and at the same time I'm going to do the expansion as well. 5 times x, 5 times minus 1, 4 times 2x, and 4 times minus 1. Collect like terms, similar animals here. 5x plus 8x is 13x. That's an x. And then minus 5 minus 4 is minus 9 over 20. Can we simplify this anymore? No, we can't. That is the answer.